You guys thought it was out of hats. You're wrong. Today I've got this big hat for this big question. I'm super excited for this question because I found something super, super nerdy. I promise you, you haven't thought of this question this way, and you're going to love it. Hopefully as much as I do, but I doubt it because I out-nerd most of you. Okay, let's take a look. So the question is math. I'm not smarter. I just out-nerd you. Math 100, web work 11. Problem 10, find the limit, blah, 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 blah. Okay, first things first, look at my DESMOS. We got to get right over to this. Let's do that. I think I can do this. Okay. Okay, check this out. So again, it's 8x. We're comparing 8x and tan of 4 over x. Okay, this goes to infinity, obviously, as x goes to infinity. What does tan of 4x go to? Well, 4 over x goes to 0, because as x gets really huge, it fits into the 4 fewer and fewer times. Remember, that's the value of a fraction. The value of a fraction is always how many times the denominator goes into the numerator. So this thing is going to be going to 0, and tan of 0 is, well, we can just look at the graph, although you should know. You should know this. Tan of 0, we can just look at the red graph. There's my tan drawn. Tan of 0 is 0. Okay? Now, what have I done here? I've superimposed this line y equals x over tan of x. And what do you notice near x equals 0? Well, of course, it looks like it's a pretty damn good linear approximation for the red graph, right? It looks like if we get pretty close to x equals 0, our line's going to be perfect, and it turns out it will be. But you have to be very, very close. Actually, just on is the only place that's actually perfect, but you can get within any error margin you want around it. Now, that means tan of x is equal to x near x equals 0. That must mean that 1 over x is equal to tan of 1 over x as x goes to infinity. Because as x goes to infinity, this one goes to 0. And as x goes to infinity, this one goes to 0. But that's what we just said. Tan of 0 is equal to 0. Let's check. Let's zoom out and see what happens. Holy shit, look at this. Look at this. Orange is 1 over x. And black is tan of 1 over x. And what do you notice? Of course, this has to happen. There's a bunch of chaos here. But as x goes to infinity, these things are almost identical. I'm going to try and zoom in here to see what the difference is. Already, we're only at 13.7, and already they've almost entirely matched up. You have to zoom in to within a couple thousandths there. Okay, so they're almost, and that's only at 13. Imagine at 3 million or whatever. So what does that mean? If these two are the same, then you know what else has to be true? 4 over x has to be approximately equal to tan of 4 over x. And again, there's going to be chaos. That's when x goes to infinity, not near x equals 0. And if we look, chaos here, beautiful, beautiful chaos here. And then as x goes off to infinity, what do you know? 4 over x behaves exactly like tan of 4 over x. And again, that's because if we look at the original functions, if you input a 0 into the tan function, that looks the same as if you input a 0 into the x function. Okay, so this is crazy nerdy. So what does that tell us? That tells us that tan of 4 of x behaves like 4 over x. Okay, that means this is really the same thing as going ln of 8x times 4 over x. The x's cancel and you get 8 times 4. Isn't that crazy? Isn't that amazing? All right, well that's the super, if you just sit and think about it, which is what I do. I just sit and I think about it and I say, what the hell is going on here? That's what you get. You can do it the L'Hopital's way, but it's boring. You don't really learn anything. It's just a mechanical process and it's very boring. If you need to know, you just do this thing here. This little trick is always, whenever we get something going to infinity, something going to 0, you can always take the reciprocal, divide by the reciprocal of one of these terms. So I divide by the reciprocal of 1 over 8. Algebraically, this thing is equal to this thing. Okay, and we can see, you can calculate that if you want to, but it's very boring. I'm always interested, if something's going to infinity and something's going to 0, which one wins and by how much? I think it's weird when I get an answer like 32, and I think it needs to make sense somehow. So I think about it. Anyways, that's the cool part about this question. This is the algebra. This is what you're expected to know in your class. in the exam, I wouldn't just sit and think about the question for, 20 minutes, which is what I did. You don't have 20 minutes. I would just do L'Hopital's rule to get the question, get your marks. But it's sad that that's what they want. Anyway, that's it. That's your help for today. Shell at tallguytutoring.com. There's my company. As always, if you want me to help you personally pass your course, you can click in the description below and sign up for newsletters. Oh, by the way, also I have this Desmos graph down there. And yeah, or shoot me an email at tallguytutoring@gmail.com and I will help you, of course. Anyway, hope that that was fun. Okay, talk to you later. Till next time.